And we are live. Welcome everybody for this live stream. Today is going to be really exciting because we're going to build a super cool blockchain app. So you will not only learn something new today, but you will also be able to make money because this is a very special app that you can actually use to make money. No, it's not bullshit. It's actually true. You will understand. So we are going to code this step by step. And so we will use JavaScript for the front end because this is going to be, even though this is a blockchain application, there will be a big part that is actually a web application. And this web application will connect to the blockchain. And we will also have to code a smart contract on the blockchain using a programming language called Solidity. So there will be different parts for our blockchain app. Before we get started, very briefly, if you are new here and you want to learn how you can get started as a blockchain developer, check out my free roadmap. This is a free training that is going to explain everything that you need to learn to become a blockchain developer and how you can get your first blockchain job starting from zero. It will save you a lot of time, so check it out. I put the link in the chat, eattheblocks.com/roadmap. All right, so do we have anybody in the chat? Where you guys are from? So we have Vibing, we have Mayank. Yeah, tell me where you guys are from and give a like to this video. We need some like, guys. So what are we going to build today? And the surprise, this. So we are going to build a meme coin generator. So the idea is that with this app, we will be able to create a meme coin even if we have zero coding experience. So of course it's not for us, it's more like for end user, but this is a very, very useful app because right now, basically there's this crazy frenzy about meme coins. So a lot of people want to create meme coins and turn out, if you're not a blockchain dev, it's not really easy to do it, but we will make it easy for everybody. So basically with this app, the way it works is you put the token name, you put the token ticker, the details about the tokenomics. I will explain later what this means. You click on the deploy token, and it's going to deploy a token on the blockchain. So we are going to target the Base network, which is an EVM compatible blockchain. So if you are completely new to the world of blockchain, what does this mean? Basically, there are different blockchains that we can target, but we are going to choose the most popular blockchain technology, which is Ethereum. But the technology of Ethereum is not only used on Ethereum itself, but also on many other blockchains. And right now, one of these other blockchain that uses the technology of Ethereum is called Base. That's a blockchain that was created by Coinbase, which is a big crypto exchange. And what is good on Base is that the transaction fees are much lower than on Ethereum. And because of that, meme coins are really popular on Base, actually more popular than on Ethereum. So it makes sense to get started with this chain. All right, so I also told you that you will not only learn how to make a blockchain app today, but I also told you that you will be able to make money from it. So why is that? Because once you know how to make this project, basically you can deploy it, and basically if you send traffic to it, people will pay you to use it, and I will explain you how it works. So basically the way we're going to implement this token generator is that every time someone uses it, we are going to basically we can implement a fee system where we're gonna be rewarded a part of the token. Okay, so that's one way to monetize it. So let's say someone create a token with 1 million units. Well, maybe we can get 0.01%. That's our transaction fee. Or we could also have a fixed transaction fee. For example, it costs 300 USDC to use this, or it costs some Ether. We choose what we want, really. So that is the project. The first thing that we want to do is to create our ERC20 token. And that is basically, we will use this token as a template that we're going to reuse it for every new deployment. Every time someone use our token generator, we're going to use our template. So for that, to create our smart contract, we are going. So first of all, let me talk briefly of ERC20. Okay, so because basically a meme coin, that's what we call an ERC20 token. So an ERC20 token, it's a standard for a very specific, specific type of a very specific smart contract. So it represents an asset that is fungible. So basically, like money. And so we, the community of Ethereum, have defined a standard. So basically, you have like a series of function signatures that you need to implement in your ERC20 token. Like, what's the name of your token? What's the symbol? Symbol is like a couple of letters to identify your token on exchanges. Decimals, this is basically how many cent, basically how many elementary unit in your token. Total supply, so how much token there is. Balance of, so that is a function that will tell you how much tokens you have. Transfer, so this is a function to transfer the token to someone else. Transfer from, this is to allow someone else to do a transfer on your behalf. Approve, so it works together with transfer from for delegated transfer. You can also know the allowance of someone. And then event, where basically we won't spend too much time on this, but this is to help external application to track all the transfers that happen on this token. And so we have the function signatures. And so if we create an ERC20 token, we need to have exactly all those function signatures, but it's up to us to actually write the code. So in most cases, people don't write the code themselves. What they do is that they use a framework called OpenZeppelin that makes it really simple to write an ERC20 token. And the advantage is that the code is going to be very secure because it's been audited many times. So in production, this is what you want to use. But the problem is, in a tutorial, it's not really fun to use OpenZeppelin because you basically don't learn anything. So we are going to code our ERC20 token from scratch. So for that, we are going to go to a website called remix.ethereum.org. I'm gonna put this in the chat. All right, and so that's an online coding tool for smart contract. And yeah, you don't have anything to install. You just load it in your browser, and right away, it doesn't matter if you're Windows, Mac OS, Linux, it will work exactly the same. And so right away, you can start to code smart contract. So once you are on remix.org, you are going to create a new smart contract. So you go here in the file explorer on the left. Don't worry, I'm going to increase the size when we start to code. And here we gonna call our contract ERC20 token.sol. All right. And after, what we're gonna do is we're gonna start the coding. So here, basically the name, the extension for smart contract is .sol, and we're gonna use a programming language called Solidity. That's the most popular for smart contract on Ethereum. So first we specify the version of Solidity like this. So we're gonna use the latest version, 08.25. We finish our statement with semicolon like this. And after that, so there is something a little bit obscure. I'm not gonna spend too much time on this, but yeah, the compiler of Solidity want us to add this license comment. Anyway, so let's keep going, and we are going to define our contract. So here we use the contract keyword, then the name of the contract. And so you can see this basically as an object that is going to encapsulate your data and your functions. And everything that is, we encapsulate everything with curly braces. So here we are inside the token, and here we are outside. Okay, so first we're gonna define the variable of our contract. So we're gonna start with the name. Okay, we'll have a name. So in Solidity, names have types. So here this is a variable of type string. Public means that we're gonna be able to read this variable from outside of the contract. Then a couple of other variable. So here, that's basically the symbol. We also call this the ticker. So that's an abbreviation that will be used to identify the token on the exchanges. After, we're gonna use the decimal. So this tells you basically what is the elementary unit of this token. So here uint means this is gonna be an unsigned integer. So basically a positive integer, 1, 2, 3, etc. 8, it's gonna have 8-bit. So that means it's gonna be represented with 8 bits, 0, 1, 0, 0, etc. 8. So they are basically, you can go from 8 to 256 in Solidity, but here this is a small integer, so we only need 8 bits. All right, then we're gonna need a big integer, the biggest one possible for the total supply. So total supply is how many tokens will be available. All right, so these are our basic variable, and now we need what we call mapping. So mapping, this is to this is a container. This is to represent a collection of data. So in JavaScript, the equivalent will be an object, basically, with which is basically a key value store. So this is what you would have in JavaScript, but in Solidity we have mapping, and so we defined type of the mapping. So that's an address. An address basically will identify each owner of the token. So I can have an address, you can have an address, everybody can generate an address with a software that we call a wallet. And it doesn't cost any money to generate a wallet. And each key is going to be mapped to uint256. And so this is gonna tell us the balance of the different people. So for example, 0x whatever is gonna have 1000 token, then 0x whatever is gonna have 1500 token, etc. So everything will be stored on this mapping. Are you guys following? Yes? If you are still with me, tell me in the chat. We are still here, Julian. Okay, I want to see some action in the chat. All right, so next mapping. So we need to track the allowance. So basically, who approved which address to spend money. So this is a bit advanced, but this is basically in the specification of ERC20 token. So we just need to do it. And you can compare this with credit card, for example. When you buy something online, let's say you buy a subscription. So when you click on the button to buy a subscription, technically what you're doing is that you are allowing a merchant to spend your money every month. So you are giving an allowance to the merchant. So that's basically the same ID here. We can also have allowance. So we're gonna have an address that maps to an inner mapping. So a little bit more complex here, but that's because we have two addresses involved. We have the address of the owner and the address of the spender, the other person that was allowed to spend on your behalf. And so here we're gonna have the key of the inner mapping is an address, and it's gonna map to uint256. Okay. And here public allowance. Okay. Right. Then once we have the allowance, we need to define the two transfers. So transfer is not very interesting, so I'm gonna cheat a little bit and just copy paste here from my cheat sheet. Basically, this is for outside application to keep track of who sent what. All right. After that, we have the constructor. Constructor is very important. The constructor is a special function that will be called only one time when you first deploy the smart contract. So here we're gonna have a couple of value of arguments. Sorry. So first, the name. So basically, all those variables that we have here, we need to have them in argument as well. So here. String memory, sorry, symbol. What else? uint 8 for the decimals, and finally the last one is uint 256 for the total supply. All right, and we open the constructor. Okay, so memory, name, yes, symbol, decimals, and total supply. All right. So after we're gonna have to initialize all of this. So here we have the name. Here we have the symbol. So here, this means whatever we provide in argument, you're going to put it in our variable name here. And this is going to be stored on the blockchain. Symbol, right? Decimals. So here's some pretty straightforward code. Right. No, here's total supply. All right. So far, it's okay, right? It's not too difficult. So here we have a constructor. So basically our initialization code. Next, we're going to create the transfer function to transfer token to another address. So here first the recipient of the transfer, then the value that is being transferred. And after that, we're gonna have a special keyword. So public means that it can be called from outside of the contract. And then returns. So this allow you to get some feedback from the function. All right. And so here first, when you want to transfer money, you go to the bank, okay? And what's the first thing that the teller is going to do? It's going to check your account, and they want to make sure that you have enough money, right? So here, this is the same thing. We want to make sure that you have enough money. So for that, we're going to use a special statement in Solidity called a require statement that basically is going to test the condition. And if this condition is true, is just going to go to the next line. But if it's not true, it's going to throw an error and the whole transaction just stop there. So that's, you use this to check some condition. All right, so we are going to check that you have enough. So for that, we're gonna use the balance of function. Let me see. The balance of mapping. Sorry. So here I meant to call this balance of. Okay, balance of mapping, and we want to extract a specific entry. And so the address of the caller, the sender of this transaction is MSG sender. That's a built-in variable in Solidity, and you have nothing to do. You are guaranteed that this is going to be the sender. So that's very, very useful. And we're gonna make sure that this balance of is superior to the value that we want to send. And if that's not the case, then you can have an error message like not enough or something like this. Then what we're gonna do then, so once we've checked that, we are going to adjust the balance of. So we're gonna start with your balance. We're going to remove the value that you want to send, and we're going to, so here this is the decrement operator. So basically this is equivalent to if we did this. That's the same thing. All right, so you take what you have before, you remove the value, and then you save everything back into balance of MSG sender, right? But here it's just more elegant to do it that way, so we do it that way. And for the recipient, so that's the other way around, we're going to use the increment operator. So the recipient is going to be _2, and here is going to receive the value. All right. Okay. Then once we have this, we're gonna emit an event. So we have to do this because that's in specification of ERC20. We have to implement events. MSG sender, that's the sender, that's the recipient, and here is the value. All right, boom. And after we return true. So that means everything went fine. Okay, so we have our transfer function. Amazing. So now in our token, we can transfer some token to someone else. The next thing that we're going to do is the approve function. So that's for delegated transfer. So first we have as argument the spender, then how much money this spender is allowed to spend. So here we make it a public function, so it can be called from outside of the blockchain. And here we're gonna return true if this is working. So first of all, we are going to update the allowance mapping. So yeah, here we've defined the allowance mapping. And so first the allowance of the spender is going to, let me see. So first of all, the first key here is the owner, okay? So of course, only the owner can allow a spender, okay? Because otherwise it doesn't make any sense. If I allow a spender for your account, you're not gonna be very happy, right? So here, that's the same thing. We can only do it for yourself. So here, because this is MSG sender in key, we actually don't need a required statement because we know that you can only allow the spending for your own account. That's it. MSG sender, then the second key is the key of the inner mapping. And here, you might be tempted to do something like this, _value. But if you do this, it's actually wrong because you overwrite the previous value. So let's say you allow someone to spend, I don't know, $1,000, and then you allow this person to, what am I saying? No. Forget what I said. I got mixed up. No. Every time you call approve, you basically redefine the allocation of that person. So if before you approve that person for $100, and tomorrow you approve them for $1,000, and it's not 100 plus 1,000, but it's just the new value is 1,000. So that means if you want to remove the allowance completely, you just call the smart contract again with an allowance of 0, right? All right, so now we have our allowance. Then we're gonna emit an approval event, because we have to have an approval event in the standard of ERC20. Okay, approval, and you're gonna have a spender, a value. All right, and we return true, and that's pretty much it for approve. All right, some water. Let me increase the aircon here, because it's getting hot in my recording studio with all my studio light getting really hot. So all right, so after approve, we're gonna do the transfer from function, so delegated transfer. So the function signature is similar to transfer, but a little bit different, you will see. So first we have the owner, which is from, then we have this the recipient to, then we have the value that we want to send, so the, underscore value. Then this is a public function. Then it's gonna return true. If it's gonna return true. All right. Then inside we are going to do some check. So first we need to make sure that the owner has enough. So here, let me copy paste this require statement, because this is going to be a bit similar. So it's not MSG sender here, but it's from, and it needs to be superior to value. Let me see, is it yeah, that is correct. It needs to be superior or equal to value. Then what else do we need? We need another require statement, require, but this time we need to make sure that the allowance is enough. So allowance of the from, and then the second one is the spender, so that's MSG sender, okay? And this needs to be superior to the value that we want to send. Otherwise, here our error message. Okay, so now we've done our check, and next we're going to update the different balances. So you know what? Let me copy paste those two lines. So we're going to decrease not MSG sender, but from, increase to, so that's the recipient, and we also need to update the allowance mapping. So for that, let's select from, let's select no, here from, then MSG sender, and we're gonna decrease the value that we just spent. So basically, let's say you allow me to spend $1,000 on your behalf. So let's say I spend $500 on your behalf. Now my allowance is 1,000 minus 500 equal 500. And after, we're gonna emit an event. So because that is a transfer, even though that's a delegated transfer, but still count as a transfer. Return true in case of success. Okay. And that's that's basically it. So we have our smart contract here. So with this, now we're gonna use this template in our token generator. Every time we want to deploy a new meme coin, that's the template that we are going to use. So the next part of our blockchain app is basically a web application. So we're gonna use what we're gonna use. We're gonna use JavaScript, of course. What else we're gonna use? We gonna use Ethers.js. So Ethers.js, this is a library that is used to interact with the blockchain. So you strictly speaking, you don't need Ethers.js. You can write some JavaScript code that directly interface with your smart contract. But the problem if you do this is that the API of Ethereum is actually really complex. So you don't want to do this. You want to use a library for that. And so there are several, but for JavaScript, Ethers is the most useful. So you can use it on the back end and also on the front end. What else we're going to use? We are going to use a JavaScript framework called Next.js. So that's basically React, but on steroids. And so with Next.js, we're able to quickly build dynamic front-end applications because we're going to need some level of interactivity, and Next.js offer us this. And also Next.js make it really easy to start with React. Otherwise, you have all this boilerplate code, super annoying. So Next.js, amazing. We're going to use it. And what else we're going to use? So in terms of blockchain, as I mentioned, we're going to connect to this blockchain here, that's basically a blockchain based on the Ethereum technology. What else we are going to use? We gonna, for our CSS, to make it beautiful, we're gonna use Bootstrap. You know, that's a CSS framework for lazy developers like us who don't like to design but just to code. And the last thing, there's still one thing. Sorry, still one thing we need. And the last thing we are going to need is MetaMask. So MetaMask, this is a wallet for Ethereum. So that's a software that you will use as a user. So if you are very new to blockchain, you can compare this to your password manager, really. Because on the blockchain, we don't have password, but we have what we call private keys. It's like a password. And this private key allow you to perform some actions on the blockchain. It can identify you. You can spend money, or you can execute functions on smart contract. And so every user has a wallet, and so MetaMask is the most popular one. And that's a Chrome extension. So you can install it by going to the Chrome Dev Store, and it's going to add a little fox here in your browser. And after that, you're going to be able to create a private key. So basically the secret that is inside the wallet. And you're also going to create an address. So I mentioned briefly an address identify each user. Let me see, Ethereum address generator. All right, so here, let me generate an address. With this website, you can generate an address, and you can also generate the associated private key. So MetaMask is gonna do these things for you, but in a nicer way. You just open MetaMask, and then you have access to different accounts. So here you can see one of my addresses is 0x something, and you can see how much money I have. So we're gonna need all those tools. But first, we are going to start by setting up the project. Okay, so for that, Oh, and I forgot one thing that we're gonna need. So we're gonna need Node.js. So that's basically JavaScript, but on the server. And so we're gonna need it to for our development tools. You can install it no matter if you are on Mac OS, Windows, Linux. It just works all the time. Okay, so I'm gonna open my terminal, and inside I'm gonna use the npx command. So that comes with Node.js when you install it, and I'm gonna use a command called create next app. So this allows you to create a new next application. It's gonna use the latest version of Next.js, and then you need to give it a name. So let's do meme coin generator tutorial. All right. So do I want to use TypeScript? Of course, no. I don't want to waste my time. ESLint, no. Tailwind CSS, no. We're going to use Bootstrap. SRC directory, yes. App router, that's the default. No. All right, so now it's gonna install everything. So should be fast, okay. And now let's go inside our project. And after, what I'm gonna do is I'm gonna open VS Code. VS Code. So if you're new to coding, VS Code, that's basically the most popular code editor. You can use it to code any kind of project, web project, Solidity, smart contract, everything you want. So I've already installed VS Code, but if you haven't yet, you can do it, or you can use whatever code editor you want. And so one easy way to open VS Code is to do code dot. It's going to open VS Code right in this directory. Okay, so now let's see what we have. Let's resize this. Let's increase the size. Okay, I think that's big enough. So I'm also going to open the terminal. There is a built-in terminal inside. And so here in my terminal, what I'm going to do is I'm going to install some dependencies that we need. So that's basically some extra code. So for that, you type npm install. Npm, that's the package manager of Node.js. You can install a lot of code very easily like this. So we're going to need Bootstrap, the CSS framework. And what else? We're also going to need Ethers, the JavaScript framework to interact with the blockchain. All right, so let's press enter. Now, if we check, so let's lower the terminal. And if you check package.json, now you should see Bootstrap and Ether. Okay. So we have everything we need. So the next step is you can do npm run dev in your terminal, and it's going to launch the server. And so now, if you go in your browser, you go to localhost 3000, you should see this. So that's basically the default boilerplates for Next.js. So it just means that everything is working. Of course, that's very different from what we're going to do at the end. So we're going to do some setup here. Because there are a couple of things that we don't need. So this CSS file. So yeah, first of all the code will be in src/app directory. Okay, so you have a couple of files here, but the most important is page.js. So that is the JavaScript code that is going to execute the home page. So we're going to spend most of our time here. And then you also have some CSS code. So page module.css, global CSS, and then layout. This is to do some initial setup. Okay, so here let's do some cleanup. So page module, we don't need it. global CSS. So let me see. This one. We're just going to copy paste some basic CSS code here that I have. So it's very simple. It's just some basic stuff. I'm going to rename this to styles.css. Okay. So then in the layout file, let me see what we have. Okay, so let's do some cleanup. So first we need to install Bootstrap. So this is how we do it. Then here, let's import our style sheet. So very important that this is after Bootstrap, because it's going to, if there is some conflicts between Bootstrap and our style sheet is going to overwrite Bootstrap. Then here for the metadata, so that's what you will see in the tab of your browser. So let's customize this meme coin generator, and then the description. So that's the SEO description. Generate your meme coin in 1 minute without any coding. Okay. What else do we need? Okay, so here let's remove that. Let's simplify this, and I'm going to add some font from Google, some Google font. All right, so here I add a head statement, a head block, sorry. And so I got this code that you see here. I got it from Google. So I'm going to import two fonts, Permanent Marker and Montserrat. And if you wonder how I got these codes, it's very easy. So here it means our app is broken, but that's okay because we haven't finished yet. So you just go to Google Font. What you do is you type what you want. So I don't know. I think I typed something like you type a keyword here. Oh no, here this is the word that they're going to show you on the right. So meme coin, for example, and then it's going to show you some this word with a different font, and so you click on the one you like this one, for example. Then you click on get font, then get embed code, and here basically you copy this and you put it here. You're gonna have some let me see. Yeah, you're gonna have just some slight modification to do because React here, this is not normal HTML code, this is a React code. So there are always a few differences with the basic code that you see online. So for example, here you need to put it uppercase and put this true, but all of this you can figure it out with the error message, because you will see error message in the console in your web browser, and they will tell you exactly what to correct. So anyway, I've already done it, and this is not the most interesting, but basically I just customized the style here. All right, so here I think we're done for the layout. So finally, let's do something more interesting. Let's remove this, and here we're gonna do a lot of cleanup. Let's save this, and now if we go back, okay, well now still some cleanup to do. Let's remove this. You know what, let's remove everything. Okay, let's just do div. Okay, hello you. Now hello. Okay, awesome. So we need to start. Let's start with the basic. We're gonna start with the HTML layout. So I'm gonna cheat a little bit because otherwise I have too much code to write. You know what? Let's type it. Let's type it. Let's be courageous. Okay, so we're gonna have three. So first of all, we're gonna use the grid system of Bootstrap. So we start with a container fluid. So basically, Bootstrap has a grid system where you can set up the layout of your page by using a grid, and to tell to Bootstrap which element represent which part of the grid, then you use classes. For every time you use a functionality with Bootstrap, it works with classes. So for example, the base of a container is container fluid. Then here we have some utility for the margin. So here just some stuff for the layout. This is to center everything. Right. Then what else do we have? So this is the first one. Then the content. So let's close the div. And so content, that's because we have this is for custom CSS. All right, so here not custom CSS for content. Yeah, we're gonna specify a max width, because otherwise it takes the whole width of the page and it's not very beautiful. Then we're gonna make it a row. So that's for the row. That's for the Bootstrap grid system. Then we're gonna define an inner div. And with this, we'll be able, with this inner div, we'll be able to have a center content. All right. So next, we're gonna have the title of the, let me see, H1 ID title, and we're gonna make it bold. So this is a utility class of Bootstrap. I'm gonna call this meme coin generator, and after that we're gonna have a short explanation of what it is. Subtitle. So let's put some class here, so we want some space from above. Make it bold. All right. So first of all, generate your meme coin in 1 minute. And here a break line, so we go to the next line. And after it's gonna be without any coding. Okay, so let's see how does it look like. Okay, cool. Meme coin generator, generate your meme coin in 1 minute without any coding. Okay, not bad. So here I would prefer if it's centered. Okay, so let's use a utility class of we're gonna use a utility class of Bootstrap. So we're gonna wrap everything in a new div with the class text center. Bam, bam. Okay. Okay, so now it's centered, and I like to underline generate your meme coin. So I'm gonna put a span for this. I'm gonna wrap it with a span. And in my CSS here, I have, yeah, I've put this rule, and that's going to underline, but with a different column, a different color. So if I want the same color, I don't need this span. I can apply directly I can directly underline it, but I want a different color, so I need to add a span. Okay, so let's see here what we have. Okay, so yeah, look slightly better. So back to our page. By the way, are you guys still following? Are you guys still in the chat? Say something if you're in the chat. Say hi. Anybody still alive? So what else do we need after that? We're gonna need the form. Okay, so the form to create the token. So for the form, we're gonna have different section. So we're gonna have the metadata, and we're gonna have the tokenomics. Okay, so two sections. So let's start with the metadata. So we're gonna have a smaller title. All right, I see some people in the chat. Okay, so people are still with me. Awesome. So class name, and so how are we gonna do that? So let's put a margin on top of it so that it's not too close from the previous section. FW bold. We're gonna make it bold, and we're gonna call this meta data. Right. And another utility class. I forgot why this is for, but this is in my code, so this is needed. Yeah, those classes, those utility class from Bootstrap, sometimes they can be a bit cryptic. So now we're gonna define a form group, because that's how you need to wrap your input by a form with a form group with Bootstrap. Is the way Bootstrap works. Then the label for this form is gonna be the token name, and after we're gonna put the input, so text input, the class of Bootstrap, and some placeholders. So before we enter something, enter token name, then we give it a name. So it's just name. Then the value is going to be, so we're going to have a state. Okay, so you know what, for now, let's the value is going to be nothing, right? And we're going to have an onChange also property, but let's not do it too fast. Right, so now, yeah, let's remove this. Let's remove this. Okay, let's see if it compiles. Okay, yeah. So metadata, token name, and here. Okay. So after that, we're gonna have the next one. So you know what? Let's copy paste everything, because this is going to be actually, yeah, let's copy paste everything. So here is not token name, is token ticker. So, and if you wonder where those things come from, they come from what we have in our smart contract. Because when we deploy our smart contract, so we will need to provide all those arguments: the name, the symbol, the decimal, the total supply. Okay, so we need a form to collect this info. So token ticker and here's gonna be a placeholder is just gonna be ticker. Right. So let me see. Yes, token name, token ticker. Okay, perfect. Then we're gonna have another block, but this time it's gonna be for the tokenomics. So let's duplicate all of this. It's gonna save us some time. So tokenomics, and the first one's gonna be decimals. So that's the third argument of the constructor in the smart contract. It's not gonna be text this time, it's gonna be a number. And the placeholder is gonna be just decimals. Name, just decimals. And after decimal, the last one's gonna be total supply. Total supply. Okay. And this is also a number. And what else? Here we're gonna placeholder is gonna be total supply. And the name total supply as well. Okay, so let's see this. Token name, token ticker, decimal, total supply. Amazing. So next we need to we need to map this. We need to store we need to save those value into our state. So whenever we change the value of the input in those form, we want to save the data in our React component, because we're going to need it after when we deploy the meme token. So for that, we are going to define a state. So we go at the very top of the contract and we define a state. So token data set token data. So if you're new to React, basically a state is a way to this is how you define this is how you can keep the state of a component in React. So the first variable is the state itself, and the second one here, this is a function that you can use to modify this state. And after you use a special function called useState, and actually you have to import this function from React. So import useState from React. So I told you at the beginning that Next.js is a framework that is based on React. So here you can see that we already have React installed. And use state, and we're going to give it a basic state, the initial state, sorry. So the initial state is going to be an object with the different values. So name initially is empty, then ticker empty, then decimals empty, then total supply empty, right? And if we just do this, actually Next.js is going to complain because by default Next.js is going to render the component on the backend, but when we use useState, that means we have a stateful component that is dynamic, and so we cannot have a dynamic component in the backend. So in order to say that this is a front-end component, we're going to put a directive use client, and this is a Next.js thing. Only Next.js understand this. Okay, so use client. Okay, so let me, the front end hasn't changed, but it's still working. Okay, And so now we need to update those values when we change the input. So how are we going to do that? Well, we're gonna create a function for that, special function that we're gonna call handle input change, and here this is the event that we're gonna get from React, and thanks to this event object we're gonna get the value of our input. Right, so here in this event object we're gonna extract the name of each input and the value of each input. Target. So yeah, all right. And after we are going to update the state, so set token data, and we're going to do it in a smart way. So because basically we only want to change the value that has changed. We don't want to overwrite the other value. So we're gonna do it in a nice way. I'm gonna show you how. So here we are going to use the spread operator, 3 token data. So basically what it's going to do is it's going to create an object with all the fields that are inside token data. So here we're going to have name, empty, ticker, empty, etc. This is what it's going to do. And after that, what we can do when we have this spread operator is that we can concatenate this object with we can basically put we can put another key value pair just after that, and this key value pair is going to overwrite the corresponding key inside token data. So I know it sounds a bit confusing, but basically here, let's say for the name, let's say we have total supply, okay? Let's say this is total supply. So here I told you token data, this is basically the previous state. And here we're gonna have total supply with the new value. And so this key value pair is going to overwrite the corresponding key value pair in token data, but it's going to leave the other one like they were before. So we just update what we want. So that's a very elegant solution. All right. And after that, we're gonna connect that to, we're going to connect it to our form. So how we will do this? So first of all, here the value, we need to map it to our state. So here it's gonna be token data dot name, and here on change, and we're gonna have, just give me 1 second. On change, so this property allow you to attach a function whenever to trigger a specific function when an event occurs. So here, whenever the value change of this input, we're gonna trigger a new function. The function we just defined that we call handle input change. And handle input change is going to be passed an object, the event object that contains the updated value. All right, and we're going to do the same thing for the other. So the second one is the ticker. Okay, so token data dot ticker. Then on change, so handle input change, you know what, let's copy this because it's gonna be the same for these two. All right, and here we're gonna have token data dot decimals, token data dot total supply. All right, and now what that we have, so now we are able to save the state of the form in our React components in JavaScript. So the next step will be to submit the form. So we're going to create a JavaScript button, a HTML button, sorry. We give it this some class of Bootstrap, so button primary, and some margin at the top. And when we click on it, we're gonna call a new function called deploy token, and we're also going to disable it when we are deploying the token. So this is a new state that we're going to create. And after that, we give it a name. So we're gonna call this deploy token. All right, so next we need to define the deploy token function. Let me see. Deploy token, and this is going to be an async function because we're going to use await inside. And here, let's console log this, and also want to console log the state to see if the state is updated. So token data. Right, and we also have the deploying state that we need to define. So let's define it here. Deploying, set deploying, and what else we need? Use state. So we start with false statement. I mean, originally we are not deploying, so the initial value is false. Okay, so it seems like we have no error. Let me see. All right, so now let's try something. So here, okay, deploy token. And let's see in the JavaScript console. And here we see deploy token. It's probably a bit small on YouTube, but here this is deploy token. We can see it here, and the object. Yeah, we see the up-to-date values here, the decimals, name, etc. Awesome. So it's working. That's great. So now let's go back to the code, and what do we need to do next? So we need to make a plan for the deploy token function, because it's going to be a big function. So there will be different steps. The first step will be to connect to instantiate connect to MetaMask with Ethers. Okay, so what happened is when you use MetaMask, MetaMask is going to inject a JavaScript object in your application and in the JavaScript environment of your browser. And so your application will be able to interact with MetaMask by using this object. And we will see how. So we need to connect to MetaMask. That's the first thing. And the second thing will be to create the deployment transaction. So so here we'll need to create a transaction that has a different that has the field, the value that we pass here in the form. Okay, so all the metadata, the tokenomics, etc. So we need to create a transaction with those value, but at this stage we are just creating a transaction. We are not sending it yet. It's another step. And after we send the transaction, all right, so really 3 steps. So let's do this. So first step is a connect to MetaMask with Ether. So how are we going to do this? Well, first we need to import Ether. So we do it like this. If you remember, we already installed Ethers before with npm install, so that's why we can access it. And after, let's use it. So we're gonna get an object that is called a provider, and you're gonna see after how it's useful. So we get it with Ethers, and Ethers has something called a browser provider. This browser provider allow you to connect to MetaMask, and MetaMask, I told you, it inject a JavaScript object, and this JavaScript object is called window.ethereum. So it's a bit misleading because we don't see the name MetaMask inside, but that's MetaMask. All right, so now with this object provider, we can interact with the blockchain. But you have to understand that the connection with the blockchain is through MetaMask, okay? So it's like this, our application, just to make a little schema, application, MetaMask, and then MetaMask blockchain. It works like this, but we only handle this part. All right, so here we have the provider, and the next thing what else do we need? Let me see. Oh yeah, another thing we're gonna need to send the transaction is a signer. So provider dot get signer, and when you do this, and the user, if it uses your app for the first time, it's going to see a pop-up of MetaMask that say, hey, this app want to connect to MetaMask. Do you allow it or not? But only the first time. And what this, the permission that the user gives, of course, it's not the permission to see the private key, and the private key never leaves the wallet. Okay, that's otherwise users will get hacked. It only means that the application will be able to see the address of the user on MetaMask. And we have this extra step because for privacy reason. Otherwise, all the blockchain app can just spy and tell, okay, this user has this address, etc. So, so this is only for that. Okay. So. Someone is asking, will there be a feature for selecting the network? I'll talk about this after. So now we're gonna create a new deployment transaction. So first, before we can create a deployment transaction, we need an object that represents our token. So let's call this token. And we're gonna use the contract factory of Ethers. So we need to import it. Contract factory. All right. In the contract factory, we're gonna pass two things. One is what we call the ABI, and the other one is the bytecode. So the ABI is a JSON object that defines the interface of the smart contract. So it allows JavaScript code to know how we can interact with this contract. And the second thing, the bytecode. So that's basically the code of the smart contract. But why we don't say Solidity code? Why it's bytecode? That's because on the blockchain, Solidity is actually not deployed directly on the blockchain. Solidity is compiled to what we call EVM bytecode. So this is a series of low-level instruction like push 60, push 80, add, etc. So the blockchain actually only understands this low-level language. And it's very similar to what we have with computers. So, you know, the CPU doesn't understand JavaScript or Python, etc. So all of these are high-level languages that are compiled to what we call assembly, very low-level instruction, basically 0 and 1. And it would be impossible to program with just 0 and 1, or only with very simple program. So this is the same thing for smart contract. Everything is compiled to this low-level thing. And let me show you how it looks like. EVM codes. So here on this website, you can see all those elementary operation, and each of them have a code. So 00, 01, and then they have name, addition, multiplication, etc. And so here we need this bytecode. So two things, the ABI and the bytecode. So where are we going to get that? Good question. So first of all, these two information take a lot of space. So we're going to create a new file for that. And we're going to call this token token.json, right? And we're going to remix, okay, and we're going to compile our token. So here you select the compile tab, so that's this one. Click on compile, and then you will see two things, ABI and bytecode. So that is quite small on my screen, so probably you don't see very clearly, but basically here, that's where I'm moving my mouse. So you have ABI and bytecode. So let's click on ABI. Let's go on token.json, and here we're going to create a new key called ABI. And we're going to paste this inside. So let's paste this, and yeah, it looks like this. So that's a JSON object basically, and yeah, so no, there's no double quote here. You can put it directly like this, and so it's going to describe each function. Let me see. So yeah, here the allowance function. So it has this output, the argument, etc. This is a language to describe your smart contract. All right, so that's the first key. And the second key we're going to need is the bytecode. And so for the bytecode, we go back to Remix, we click on bytecode, and sorry, we're going to paste it. And so you can see that's not really human readable. So that's just a series of number. And remember, I showed you before here, EVM code. So these are all those numbers. These are those opcode here. Okay, so we have all the required information. So let's go back to page.js, and now we're going to import token.json. So token.json from token.json. Okay. And so now we can get our ABI. So token json.abi, token json.bytecode. All right. Okay. So where are we? So we have this contract. We have this object token here, and with this object, we'll be able to create the deployment transaction. So how are we going to do that? So first, let's define an object for the deployment transaction. Then we use the await keyword because that's an async function, and we use get deploy transaction. All right, and inside I'm going to put a couple of parameter. So basically all the parameter that we pass to the constructor, and here we can refer to the state that we've built before, and this state is in sync with the form that we created before. So token data dot name, token data dot ticker, token data dot decimals, and finally we have the total supply. But the total supply basically will need to, it's going to be slightly more complex. So why is that? If we just put a total supply, so let's say for the total supply we put 1000, but it's actually not correct, because if we want 1000 unit for our token, we actually need to multiply by the decimals. Okay, so usually the decimals is something huge, like 10 power 18. In most token it's 10 power 18. So that means it's gonna be 1000 plus basically many zeros, 0 0 0 0 0 0, etc. So because we don't want to ask the user to write this huge number, okay, it's really not convenient. Like the user, he just think in terms of whole token. It's not gonna bother to go down at the decimals level. So the user can just input this simply, and it's up to us to make the translation. So for this translation, how are we gonna do that? We're gonna use ethers pass unit. That's a utility, and we refer to token data dot total supply, and actually it's weird, but it wants a string to string. It doesn't want a number, and that's because under the hood it's going to use a library that is called I think it's a big number, and so big number is to deal with a very, very big number in JavaScript, because JavaScript only handle number up to 2 power 64 minus 1, if I'm not mistaken, but we're gonna need a bigger number than this. So to overcome the limitation of JavaScript, we need to use this library. So that's done by pass unit, but it needs a string. And for the other one, this time for the unit is much smaller, so this time it needs a number. So here pass int and token data dot decimals. So I know it's weird because one is a string, the other one is a number, and at the end the whole thing is a number, but it is what it is. All right. So now with this transaction object, we will be able to deploy the contract. So just to be clear, at this point we haven't sent the transaction. We just create a transaction, but that is unsigned. So it's like a template, and with this template we're gonna see MetaMask and say, hey, can you ask the user if he or she approve this transaction? and MetaMask says, sure, no problem, then MetaMask is going to show the user a pop-up and say, hey, the application wants to do this action. Are you okay with it? And then if okay, the user click on confirm and the transaction is sent on the blockchain. But this is the creation of the transaction, the creation of the transaction and the sending of the transaction are two separate steps. Okay, let me get some water. Someone told me, corrects, you missed J in token dot bytecode. Okay, thank you. Thank you very much. So. Now, let's create our transaction request. So we need another object. And the only field we're gonna put is so there are a couple of fields in a transaction, okay? There is the from field. The from field, MetaMask already know it. It's the address that is selected. The to field, when we deploy a new smart contract, it's actually going to be empty. That's a convention. If we were sending money to someone, of course, it wouldn't be empty. But now we deploy transactions, so special situation. Then what else do we have? From to value. So if you want to send money, you can specify the value object, value field. But in this case, we don't send any money. What else there is in a transaction? Signature. So the signature, this will be created by MetaMask. So at our level in our app, we don't deal with a signature. And so from to value, and the last field, nonce. Nonce, so that's an integer that is incremented for each transaction, but that's managed by MetaMask, not us. And what else do we have in the last? So gas parameters. So you have different parameter related to gas. So that's basically for transaction fee. That's also handled by MetaMask, not us. And finally, there's the data field. So the data field allow us to interact with an existing smart contract or to deploy a smart contract. This is where we will put the code of the new smart contract. So we will use this field, and so we use a transaction object and use transaction.data. All right, and now we need to send the transaction. So how are we going to do this? So for that, let's so we're gonna do a try catch block because it's possible that this fails somewhere, and so we want to show the user some feedback. So we're gonna have a try catch block, and so first let's send a transaction. And for that, we use the signer that we defined before. And there's a function called send transaction. And we put the transaction request in it. So that's when the user will have to approve it. Then the second thing we need to do is to put the receipt. To get the receipt of the transaction. So at this stage, we are just sending the transaction. It's being approved by the user and sent to the network. But before it's added to the network, we need to wait. That's what we call the mining process, or in Ethereum 2.0, there is a different vocabulary. We don't say mining, but we don't talk of miner, but of validators. But the idea is the same. Is we need to wait before the transaction is added on the network. So here, let's wait for the transaction to be mined. Transaction response wait. And finally, when we get the transaction receipt, it means it was successfully mined. And what else what else do we need? So we need two things. Okay, so now our code is working, but in terms of UX, it's not very nice. We want to provide more feedback for the user. So we're going to define a new state to show some feedback to the user. And yeah, we already have it actually deploying here. So we're gonna make use of it. So let me see. Just before we create the transaction, we're actually going to show feedback to user. Let's do set deploying to true, and just after in the UI, we're gonna use this state to show something. Set deploying, okay, and here set deploying to false. All right, and correct, say we missed the button to connect wallet. Well, actually, because of the code here, let me see. Because of this code here, the user will be prompted to connect to our app. But we could separate this in a different step. But just to make it easier for this tutorial, I put everything at the same time. Okay, so now below the button here, we're going to provide some feedback. So let me see how we're going to do that. So if this deploying is true, what we're going to do is we're going to show a div. If you've never seen this pattern, this is what we call a short circuit operator. But this is a very simplified way of saying if this is true, then show this div. So class name, we're gonna use the alert class of Bootstrap, and there are different kind of info. So if it's info, it's gonna have a certain color. If it's an you have other classes for other color. Want some margin, no margin at the bottom, and what else? Your meme coin is being deployed. Please wait until the transaction is mined. All right. And I need to close the div. All right. So yeah, we have some feedback. And now I also want to show once we've deployed once the deployment is finished, I like to show a link to a blockchain explorer so that they can know exactly which transaction it was on the blockchain. So for that, we're going to define a new state that we're going to call deployment. Set deployment, use state, and let's initialize it with undefined at first. All right, let's go back to here when we send a transaction. And so we are going to save some data here in our state. We're gonna first the hash of the transaction. So we use the transaction receipt, and it's gonna have a field called hash. And second thing we want to store is the address of the contract. Could be useful. Right. So now let's make use of this new state. So here below that, let's show the information. So if deployment is not null, not undefined, then let's add a div. So okay, you know what? Let's just copy paste this, and this time it's not gonna be info, but it's gonna be success. And here I'm gonna say congrats. The meme coin was deployed at the meme coin was deployed at, and here let's put the address. And so for the address, how are we going to do this? So because we are going to deploy to the Base blockchain, I'm gonna put the URL of the blockchain explorer of Base, that is Base scan. But for this tutorial, we're gonna use a testnet. So testnet is basically a sort of alternative version of the blockchain that allow you to do some development, and it's free to use it because you don't spend real money. So here, this is why the URL is sepolia.basescan, because Sepolia is the name of the testnet on the Base blockchain. So that is our Base URL. And then if we want to see a transaction, it's going to be /transaction. And after that, we need to put the transaction hash. So we need to read from our state. So deployment dot, and here is hash. Yeah. All right. And what else? What else do we need? Let me see. So after that, I'm gonna open this in a new tab here, because I think it's a better UX in this case. And let's close this. And then inside we're gonna have we're gonna put some text. So I want to put basically the transaction hash, but the text of this link is going to be the transaction hash, but the transaction hash is very long, so it might break our UI. So we are going to just show the beginning. So here, gonna use a JavaScript block. Let's read from deployment hash, and we're gonna take the first 20 characters, substring, start from 0, and a 20 character target. Yeah, so I know this is not very readable, but basically this is our link to the transaction hash. Okay. Transaction hash. What? Oh yeah. And here I would like to have this, just to make it clear that this is abbreviated. Okay, so here, let me see. Let me make sure that everything is correct. So deployment. I think we have a problem of curly brace here. Let me see that everything is correct. So the div, congrats, the meme coin was deployed. Then we have the href that is closing here. Okay. Then And then why is let me see. I think we are missing a div. Okay, finally got it. Cool. So now we are showing some feedback, and the last thing I'd like to show is some error, because we might have some error. So let's create a new state for that, and use state. And originally there is no error. All right, and then in the catch block, let's show an error. So first of all, we need to, this is not deploying anymore. Okay, and error is true. And after, we're gonna show some generic error here. So if there is an error, what we're gonna do, is show an error message. Right, and this is not success, it's gonna be danger. Right, and what we're gonna put here, oops, there was a problem. Your meme coin was not deployed. Please try again later. Okay, so let's save this. Okay, so let's see the front end, how it looks like. Yeah, so seems like, let's see if we have any error in the console. Seems like not. Okay, so it's looking good to me. So let's reload this. So now the time that you were all expecting is finally this is finally the highlight of the show. So we're going to do the demonstration and deploy to Base testnet. So before you're able to do this, you need to have some testnet ether for Base, because you will need this to pay for transaction fee. So just let me reassure you, we're not talking of real money. This is fake money, but still you need to fill a form in order to get it. So what you need to do for that is you do Base testnet faucet. Faucet is the name of a kind of tool that will give you this fake ether that you need. So there are several available. For example, QuickNode, and let me see, Base Sepolia. Show me why you don't. Okay, well, let's try the one of Alchemy then. So basically what you're gonna do is, let's say, so you create your account, you create a new account in MetaMask, you copy it, you enter your wallet, and here you click on send me ETH, and it's going to send you some testnet ether. Another thing that you will need to do is configure a network in MetaMask. So for that, what you're going to do is you click on add network. And here is not going to be here. Okay, so you need to do add a network manually. And here you will say Base testnet. And then for the other information, Base testnet. RPC URL. Let me see this. So there's this website that is very convenient, chainlink.org, and it will give you the parameters of many blockchains. And here it will give you some RPC URL. So RPC, this is the URL that you need in order to send transactions to this blockchain. So here you need to try one of them. So this one looks quite official to me. Oh, Goerli. No. It's not Goerli that we want. It's Sepolia. Let me see. No. I want Sepolia. Testnet. Okay, so here's sepolia.base. Let's copy this. Put this in this field. Chain ID, you have it here. So this is a number that uniquely identify each blockchain. Currency symbol, well, they use Ether, even though it's testnet Ether. Blockchain Explorer, this is optional, but Blockchain Explorer Sepolia base. And so you have several. You have Block Scout, but there is another one, sepolia.basescan. You can put it here. Okay, and so this is useful after you send a transaction because MetaMask is going to show you a link to your transaction, but for that it needs to know a Blockchain Explorer. Okay, and then you will click on save. So me, I can't do it because I've already done it. But then once you have done that, what's going to happen, it's going to appear in the list of network here. So you're going to select this network, and then you will see that you have some Ether here because you went on the faucet before, so you have some testnet Ether. So here, even though you see dollar, it's not real money. Okay, it's just fake money. And each transaction cost me about $4 of fake money. So I mean, you can do a couple, many of them before you use all your testnet. All right, okay, so we have everything in place. So now I cross my finger, and to be honest with you, there's a very high chance that it doesn't work because when you do some live coding like this, it's just so easy to do a small mistake. But let's see. So let's say my token, my awesome token, okay, and the ticker is TTT, and we want 18 decimals. Total supply will be 1,000. So deploy token. Okay, so we have the feedback here. The meme coin is being deployed. Please wait until transaction is mined. Very, very well. So here I see MetaMask popping up. So you have to verify that you are on the right network. So otherwise you might spend some real Ether, okay? So here, base testnet. Yes, that's correct. Estimated fee, $4. Well, I have enough. This is a contract deployment. So it looks correct. So now if I click on confirm, so the pop-up of MetaMask disappears. So we send the transaction and boom, now congrats, the meme coin was deployed. That's amazing. It's working. Wow. And here we can see our transaction on the blockchain 9 seconds ago. So from 0x6f, okay, let's see that it matches our address. 0x6f, yes, so that's correct. A 2. And here I told you that there was, when you deploy a new contract, this field will be empty, but in the Transaction Explorer, you will see actually the address of the new contract. So here it tells you it was created. So let's click on it. And so this is this contract. And we won't be able, unfortunately, to read the source code. So here we can only see the bytecode, okay? And it's actually not the same. It's not exactly the same bytecode that I showed you before, because this is what we call the execution bytecode, which is slightly different from the deployment bytecode. But I'm not gonna go too deep in this. Yeah, it looks quite similar like this, like some number that's some big number that start with 0x. But here's basically all your Solidity code. And so, okay, so here we've successfully deployed our token, and that's good. But the big problem is if you leave your contract like this in this state, it's actually not very good, because people will not trust your token because they cannot know which code is deployed. They just see this weird series of figures. So we need to do an operation called verification. And what is that verification? So here's what we're going to do. We're going to show the source code to Basecamp. We say, hey, Basecamp, this smart contract at this address, it was compiled with this source code, okay? And Basecamp is not going to trust you just based on what you say. No. Basecamp, what it's going to do is we are going to it's going to compile the source code that you give it, and from this source code it's going to get some bytecode, okay? It's going to compare this bytecode that it computed itself with the bytecode that is deployed on chain, okay? If those two bytecode match, he knows that you are telling the truth. You gave the correct code because he did the computation itself, and he find the same bytecode as you have on chain. So it knows, okay, now I know this is the real source code of this address. So now on the page of your contract is going to show your source code, and people will feel like your coin, your meme token is much more trustworthy. So there are different ways to do this verification operation. There's a manual way and a programmatic way. So here we're going to do the manual way. So let's click on verify and publish. Okay, so please enter the contract address. Well, that's already pre-selected. The compiler type, so Solidity single file. So to verify smart contract is much easier to have everything in one file. Then please select the compiler version 0x. Okay, so this actually we can check it in Remix. We go in Solidity compiler. We go on, let me see, on compilation detail. In here, let me open here compiler. So this is very small, but basically we can see 0x25, the version of Solidity, and even give you a specific number of commits. So B61 something. Let me see, where are we here? B61 something. Yes, it's this one. Please select the open source license type. All right, so here this is a MIT license. Continue. All right, then enter the Solidity smart contract below. Optimization. So optimization, that's something optional that you can do to produce a smart contract that is more gas efficient. So we're not going to talk of gas too much, but basically gas means the transaction fee, okay? And it's possible to optimize your code so that you reduce the transaction fee consumption. And Solidity can help you because it has a setting. When you compile a smart contract, you say, hey, do you want me to help you to optimize it? And if you click on yes, it's going to produce a more efficient code, but the downside is that it's going to take more time. So when we are doing development, we don't use the optimizer because we want the compilation process to be really fast. But when you compile, when you do a production smart contract, then you need to activate the optimizer. So I should have used the optimizer because this smart contract was supposed to be a demonstration of a production tool, but I didn't use it to make it simple. So here we select no. Enter the Solidity contract. Okay. So what we're gonna do here, we're gonna go in remix and we're gonna select the contract. So here you need to select just exactly the contract, okay? Like nothing more, just exactly the code, because it's very, very sensitive, okay? If there's just one mistake, it's not going to work. All right, so let's paste this here. Constructor argument, so it already knows it. Then I'm not a robot, okay? And so now this is the instant of truth. So usually it's quite frequent to fail at this step, okay? Because if you just miss one little detail, it's going to fail. So let's click on verify and let's pray. And yes, success here, success. So now if I go again on the page of my contract, now I can see that the contract tab is different. I can see it's very small, but basically you have this, let me try to increase the size. So here you can see the green ticker and say contract source code verified exact match. It means me, Basecamp, have verified that this source code is really the one deployed at this address. And so here we can see exactly our contract, okay? Yes, 20 token, name, symbol, decimals, everything. And even better, now we can interact with our contract. So we go to read contract, and we can execute our function. So here, total supply. So here is 1000 times 10 power 18, the number of decimal. That's why it's a huge number. Symbol, TTT. Name, my awesome token, decimal 18, balance, and this one is the balance of, this is the function, so we need to give it an address. So for example, and actually I realized I forgot to do something very important. 0. Okay, yeah. So guys, I forgot. I made a terrible mistake, okay? But that's easily fixable. But basically, there is no token allocation. So in the constructor here, I basically should have called the transfer function. I basically should have allocated all the coin to myself. But in this case, this token is actually useless because nobody will never have any token, but that's very easily fixable. Okay. Okay. So we've done the verification. Okay, that's awesome. But there is a little problem, because if we just leave our tool like this and we just create the token, but we don't do the verification, I think user will be really frustrated. I mean, you saw how complex it was. Like even for a programmer, for us, it's already very easy to make a mistake. So of course, an end user is never going to figure it out. So we need a better process. And turns out that there is a way to make it even better. So we can do the verification process programmatically, because Basecamp has an API, and this API has an endpoint for verification. It's awesome. So you know what? We are going to do this. So we're going to do this operation just after the deployment. So for that, we're going to check out the documentation of, let's check out the documentation first. So let me check my note somewhere. Where is it? Just give me a sec. All right, so show me your endpoint, Sepolia. So Basecamp. So get contract ABI. No, don't care. Get contract source code, no. Verify source code, okay. Require a valid Sepolia API key, okay. So we can create one. It's free to do. And here it shows you the HTTP call that you need to do. So it's going to be a post. It's going to be at this endpoint. And then you have all this field. Oh my God, how are we going to do this? Oh, it's so crazy. Okay, so let's not panic, because actually a lot of those fields, all of those things, library, we're not gonna need them. So a lot of field, but we're gonna get through this, don't worry. So let's do it step by step. So let's go back in the code. So, all right, so now we're gonna do the verification. Verify the contract. So how to do this? First of all, we gonna need API key. Then we are going to need to use the send an HTTP post request. And so we're going to use the fetch function. This is the built-in function in JavaScript for HTTP call. All right. And so first, here, this is the API, the URL for the API. So let's see this, this thing here. All right. Okay, after that, we're gonna pass an object. We're gonna put some detail about our request. So first of all, the method, the type of HTTP call that we want is a post. If you are not familiar with HTTP call, this is basically a way to communicate programmatically on the web. So when you load the page, this is a get HTTP call, and so the two most common one are get and post. And post is when you want to do an operation where you modify data. Okay, so if you create some new data or you update some new data. So here, verification. It's as if you create a verification object in some sense. So this is why we use this post notation. Then header, so that is tell us what kind of data we're providing and what kind of data we're expecting. So we want some JSON object. And we will provide some JSON. Content type. Application JSON. Okay. And what else now? Okay, so after, this is going to be the body object. So this is where we're going to provide all the key. And here we're going to use this function JSON.stringify, because everything will be transported, will be embedded as a string. But to transform a JSON object to a string, we need to use JSON.stringify. Yeah. All right. Or is it true? Do I need it to? I'm actually not sure this is correct. I think I don't. You know what? I think I'm saying bullshit. I think we can do it like this. Let's try. So API key. So here, if you just do this notation, is as if you do this same thing. It's like a shortcut. All right. Then. What else we need? Okay, you know what? Let's do some copy pasting, because there are like a ton of stuff. I'm not sure we're gonna need everything. All right, so module, yeah, this is a contract, action, verify source code, contract address. Okay, so this is their example, but we don't need that. So contract address. How are we gonna read this from the transaction receipt that we got from before? And actually there's a problem of scope here because, let me see, transaction receipt. Yeah, we define transaction receipt inside the try scope, but it's not available outside. So let's change that. Okay, so now the way we've defined this, now this is available. We will be able to read transaction receipt. Okay, so transaction receipt dot address. That's what. So we deploy the contract, and after we know its address. Then the source code. So for the source code, we're going to read it from our token JSON file, but we don't have it yet. Token JSON.code. Hey, you guys still here? Yes, anybody in the chat? Say hi to me. You guys still alive? Hey, amazing for following up to here. We will be done soon, don't worry. So source code, let's go to token.json. Let's go down, and below that, it's a bit annoying. We need to comma here, and here we need to put the source code. So unfortunately, it's not possible to copy paste directly because in JSON it's not possible to have a multi-line string. So what we're gonna do instead is we're gonna go in remix, and we're going to compilation detail, and in the compilation detail is going to give us the source code in the format that we want. So let me see this. Where is it? So I need to do some research here because sources here, metadata sources. Language. Where is it? Output. Compiler input. Where did I get that? I got it from somewhere. There is a place where we can get. I guarantee you there is a place. Sources. Okay, I feel like it's. Let's try to copy this metadata and see what we have inside. I think it's here. Is there any code inside? We have bytecode. I saw it before. Where is it? Compiler, ABI. No, it's not here. Okay, let's keep searching. Compiler, settings. Okay, let's try bytecode. I don't think so. Where there is, I did it just before. Just before I did it, I guarantee you, there is a way that you can just get the. You know what? I'm going to cheat. Okay, I'm gonna take it from my own file. So. All right, so here basically you can get it from Remix. You need to do more research, but basically you need a version of the source code that is on one line, and it's going to add some character, some escape character, okay? And this is the format that we need. All right, so now we have the code, okay, cool. Now code format. Solidity single file, so this is something optional, so let's just remove that. Right. Then contract name, so that's ERC20 token. Right. Compiler version. So this we can finally find it on remix version. You can see it here. Let's put it in our token.json. Super annoying to deal with a big JSON file like this. How did I call this? Compiler version, okay. Let's go back to our page, compiler version. Then optimization used, no, we didn't use it. So here this is irrelevant because we didn't use it. So constructor argument. Okay, so that one actually is a bit tough. And also here they made this mistake, okay? Constructor arguments. So I don't know if they made a mistake or not. So basically what I did for that is I did some research because I know that in a Hot Hat, which is a smart contract framework, it's possible to do verification in a programmatic way by using the same API. So I thought, okay, well, maybe I can check out the code of Hot Hat and see how they do it. And then, yeah, and so I got some really, really valuable information. So let me see this where, yeah, so this is the plugin of Hot Hat to do the verification with a Etherscan. And so here you can see the verify function. And so a couple of things that are interesting. So first of all, in the parameter here, arguments, there is the spelling mistake. So it means the spelling mistake is correct. I need to keep it. And second, here, they give more information about the constructor arguments. They say the uncoded constructor arguments of the smart contract. So so basically we need to provide the argument we use during the deployment. But we cannot just put it in a simple format. We need to use a special function for that. So I did some research and I find the way to do it. So I'm going to show you how to do that. So first of all, you need what's called an ABI coder. You get it from ethers.abi coder. All right. And after constructor arguments ABI coder, so we use the thing we just created. And we use the encode function, and then we're going to provide two kind of arguments. So first is going to be the variable, the type of the argument, and then the actual argument. So the type of the argument, so we have a string, that's the name. Then we have the ticker or the symbol, not a string. Then we have the decimal, so uint 8. Then we have the total supply, uint 256. And then we have the actual value. So I don't remember all the values, so let me see. What am I saying? I don't remember the value. It's impossible to know it yet. So we need to read it from our state. So here token data name, token data ticker, token data decimals, and token data total supply. All right, we're almost done, guys. Just a couple of minutes. Okay, now we're good. Constructor. Okay, so now we're good with constructor arguments. So here, let's replace this constructor arguments. Then EVM version, so we can find it in Remix. EVM version, let me see. EVM version, Cancun. Okay, so let's put it in token.json. All right. Token JSON. Oh, sorry, it's not like this. EVM version. And final thing, license type. Why I don't have the comment here. Let's see the page. Where is it? Not this, not this. I'm searching for the, oh yeah, here. So license type, valid codes 112 or 1 no license. Okay, so here it seems there is a 1, 2. Okay, let's see this. So we use MIT. MIT is 3. Okay, so you know what? Let's put everything in token.json. License type. License type. Can I put 3 a number directly? Yes, I think so. Okay. So now I just need to put the API key. So for that, basically you need to go in to create an account on sepolia.basecamp.org, a free account, and then you'll be able to create an API key. So let me just do it secretly. So where is my API key? Right. Alright, so I put my key. Alright, so now we're gonna try to do the whole process. So you know what? We're gonna need to pray one more time, because I think this process is even harder than what we did before. So there's a very high chance it doesn't work. But even if it doesn't work, it's not the end of the world, because I think we learned a lot of interesting things by trying to do this. So let's do it again. ABC, AABBCC, ABC, decimals 18, total supply. All right, so now let's pray. I'm scared really scared. Your meme coin is being deployed. A base testnet. Okay. So now it's being mined. Let's wait. It's gonna take maybe like 10-15 seconds before 1 error. Okay, what's the problem? Okay, so it didn't like my access to has been blocked by course policy. I feel like, okay, I'll probably need to, if I would need to deploy it to maybe with Vercel and have a real URL, and the verification process would probably work in this case. But you know what? We've already spent enough time for today, so I think we're gonna end the stream here. But I'm just gonna have a look in the chat, see if there's any question I missed. So yeah, first of all, guys, thanks for following up to here. I mean, you are the real one, okay? Like, you follow up to the end, and some moments were really challenging, but in the end, I think we really learned a lot, because that is some really non-trivial app. And you know, if you were to if you keep building this app and you make it a little bit more polished, it could be a really nice app for your portfolio, or even if you want to do it your own project. Actually, I have plans to turn this into a real project, because I think it's really interesting. And so let's talk of how, first of all, before doing the Q&A, let's talk of the potential improvement we could do. Okay, so we could have a separate button for the connection to MetaMask. Okay, on top of it, we could have a button that says, like, connect to MetaMask. And then next to it, you could have a small widget where you show the address, your Ether balance, and the network you have selected. Then other ideas for a better user experience. So we can provide some more granular feedback. So for example, if we do several actions after the deployment, maybe we have like a first check mark where we say, okay, deployment 3 dot, and like processing, and then deployment dot. A check mark that said deployment done. Then next check mark that say, okay, now verification pending with 3 dots. And then when it's done, then verification done. So now we have two green check mark. And then every time we have a new step, basically you add a green check mark. I think it'd be really nice to have this. Then what else we can do? We could make it adaptable to different blockchain. So right now it's only going to work with the testnet of the base blockchain, but we could make it, so of course we need to make it for mainnet, but not just for one mainnet, for several mainnet, because it's not very difficult to do. User will select the network that they want, and then in our app we are able to react to those change. We can listen to the change of network, and then we change the configuration, and we know, okay, now we're on Ethereum, now we're on Base, so that means we need to change the URL for the blockchain explorer, for example. So we can easily make it multi-blockchain, as long as it's an EVM blockchain, because if it's another blockchain like Solana, for example, the code will be completely different. So I'm not sure it'd be super easy to make a tool that can do both EVM and non-EVM blockchain. All right, what else could we do to improve this tool? Many things. We could make the smart contract a bit more configurable. So for this smart contract, basically there is zero level of customization. It's just the same code for everybody, but there are a few things we could do, like for example, custom transaction fee. Some tokens, what they do is for every token transfer, they charge a small transaction fee, where you basically maybe 1% of the transfer will be sent to a charity. And for a meme token, it could be nice, like, yeah, we are the charity meme token or something like this. So make the smart contract more configurable. Then we did not implement the distribution of token at all. Okay, so that's a big problem. So several options. You can have an option where the token creator gets everything. An option where you provide an array of addresses, and you say, okay, send this much to this address, send this much to this address. So you have like some sort of initial allocation, for example. You could, what else could you do? Another step. Oh yeah, so we didn't take our fee. We didn't implement the functionality where we take our fee. Okay, so that's one more thing that we could do. What else could we do? We could provide the liquidity to an exchange. So basically, for the meme token to have value, it needs to be tradable. We need to send it to an exchange like Uniswap or something like this. But that is a transaction to do, and usually end user, for them it's quite complex to do this. So it would be nice if our tool also does this step. Another step is to burn the initial liquidity. So this is to avoid rug pull. So one more thing we could do. What else? Yeah, so that's pretty much all the functionality we can implement. If we wanted to do all of those things, we would probably need our own smart contract. So we will need to have our own smart contract that we deploy to the different blockchain, Base, Ethereum, etc. And with this smart contract, we will do the different operation, the deployment of the token, the initial allocation, liquidity, our fee, etc. And the reason why we need to do it at the smart contract level and not in the JavaScript code is because if we do it that way, it's going to be everything's going to be more clean. It's going to be cheaper in terms of transaction gas, and it's going to be a much better user experience, because now everything happened atomically, meaning that everything happened at once or it doesn't happen at all. It's not separate action. You just validate one giant transaction, and inside your smart contract, it does everything. So clearly, this is more complex than what we've done today, but that is next step, really. So that is what I would do to make this project evolve. Now, what are my plans for this tool? Because I show you a tutorial, but I don't think I'm gonna keep it as a tutorial. So I want to keep working on it up to a point where it's usable in production for a very specific use case. It's a very simple use case. I prefer to make it really good for one use case than just to make it average, but for many use cases. Okay, so I'm gonna keep it simple but make it nice. I might even create a website for token education, so that I can get some leads, like people who are interested in token. They'll probably do some research about how to design a nice token. So it could be very interesting to do some content about this. You will get some leads that are very qualified, and then I will probably monetize the tool with a percentage, a small percentage on the token allocation. And so let's say you have, I don't know, like 1,000 people who use the tool. Probably the vast majority of the token are going to be are not going to go anywhere. But if just a few of them go somewhere, then it's going to be like 100x. So it's going to be really nice. What else? And another way you can monetize it is you could use it as a way to get leads for custom development, because it's very possible that you'll have a lot of people who try to use your tool. They want to launch your token, but they realize your tool is too limited. And so at the end, they will try to contact you, say, hey man, I tried to use your tool. It was very nice, thank you, but it's not powerful enough. Do you do custom development? And yes, and you find yourself a customer, right? Then you can charge more. So that's an upsell. Yeah, so that's basically everything you can do with this project, but a lot of potential with a token maker, a lot of potential. So for those who stay up to now, if you are new here, that's the first time you watch one of my video and you don't know yet how to get started in blockchain, check out my free roadmap. I'm gonna explain you everything to make it as a blockchain developer. Okay, so let's see the chat. So is this going to be recorded? Yes, it's recorded. I was actually looking for something like this where I can learn how to create a token generator. It's perfect then. The Total ARC Films Flexony. Zeki, this man knows how to do this job. Thanks, man. Right. Film Flexony. Will you go into testing, validating? Well, I mean, I did manual testing. How could you do testing with code? I don't know, but what I would do is I would do manual testing and I would also implement some sort of monitoring. So basically, I like to know if there is some failed transaction, I like to have some code that tells me how many failed transactions happen so that I can fix something. Because otherwise, if you don't know what happened, the most important is to have some feedback. What else? Ravi, I would need to know how you can do it in Uniswap v3. Ravi, liquidity provisioning and contract compatible. What else? Will you upload this to GitHub? I'm not sure about this, and I'm gonna tell you why. Basically, so I've been thinking of what kind of offer I want to have for Eat the Blocks in the future. So we have the bootcamp, the Solidity bootcamp. That's the main thing. But I was thinking also, what can we do for projects? And maybe the future is that the tutorials will be free, but the source code will be reserved for our member. So I haven't decided yet, but it's probably gonna be something like this. So free users still get something, and paid user also get something more. Yeah, to confirm, to be determined. But I hope that you still learn a lot just by watching the live. Ranjit, well done, man. Thanks. Okay, guys, well, I guess that's the end of this stream. So thanks everybody for following up to now. And yeah, I will see you next week. See you. Bye.